Welcome you, dear students, for this class. And during this class, we will study about polarization, process of polarization, what it plays, what's the role of polarization in case of capacitance of the capacitors. So, first of all, we will go for definition, then we will discuss about the explanation. What the polarization is. What the role it plays in case of capacitance of the capacitor. Here it is. To explain the phenomena of electric polarization. Discuss how the phenomena of polarization accounts for an increase in capacitance of the capacitors when instead of air, dielectric is inserted between the plates. So what happens? What's the role of polarization? So if you look at the first one, inside this is the structure of the atom. Normally before polarization, the positive charge is always at the center, but it is surrounded by negatively charged electrons outside the circle that is in orbit. But if we see we apply some forces so that the electrons are moving to one side and the positive charges are to the other side. So this gives the concept of the polarization. Basically, this is the same types of the example. If you put your fingers inside the rubber band, you apply the force and it stretches on both sides, right and left. So stretching of these rubber bands is the same concept of the polarization in case of the atoms. Suppose before polarization, charges were purely at the center and negative charges were, it was surrounded equally in all directions by the negative charges. But what happens when we apply the polarization process? Nucleus becomes to one side and electrons gets attracted to the other side. So one side there are positive charges and other side there, one side there are negative, other side they are positive, purely positive. So it looks like that the one end is positive, other end is negative. So let's come back. This is the definition. So the slight relative shift of positive and negative electric charges in opposite direction, as I have given you example of a rubber band, stretching a rubber band, within within a dielectric induced by an external field. External electric field is called electric polarization. So what happens when an insulating material with relative permittivity epsilon r is inserted in between charge plates of a capacitor. So then negative charges appears on the left face of the positive, on the left side, and positive charges appear on the right side of the face. The dielectric, as in shown in figure, the phenomena is known as electric polarization. Why it's happening? Because it happens in case due to in between the two charge plates, and it is happening due to electric polarization. And dielectric is said to be polarized under such conditions. So this is the condition where the dielectric becomes polarized. This is basically neutral. It's not having any charge, but what we have, number of charges outside inside the vehicle. What we have done, we have applied the force, and after application of the force, positive charges are to one direction and the negative charges are to the other direction. So this type of phenomena in which we are producing the electric charges from the same atom, which is basically neutral in the nature, but after application of the process, we have moved negative charge to one side and positive charges to the other side, like stretching of the rubber band. This type of phenomena is called electric polarization. Induced charges. The charge on the dielectric faces are called induced charges. These are induced by the external field, the field which is produced by the plates of the capacitor and appears on the dielectric faces only. The electric field between capacitor plates is directed from left to right from positive to negative areas, whereas the electric field due to induced charges is from right to left. The effect of induced field on applied field. The effect of induced field on applied field. The molecules in the dielectric materials have their positive and here it is. So here it was. This is basically epsilon r. This is the relative permittivity of the material which you have introduced between the two plates. So what happens in induced charges? The charges on the dielectric faces are called induced charges. So they are induced by electric field and appears on the dielectric faces only. The electric field between capacitor plates is directed from left to right, whereas the electric field due to induced charges is from right to left. So here it is. If you look at the same, here is the positive charge. In front of the positive, there is negative charge, and if any polarization takes place, so what happens? This is basically negative charge is facing. This one is the negative charge, and this one is the positive charge. So this is negative, and this one is positive. Towards positive plate, positive charge, there will be negative side of the charge. So if you look at this one, if this one is a positive, then the negative is here. So if you look at basically the positive plate, the direction of the field is from positive to negative. It is due to the plates which is from positive to the negative. But if you look at the polarization process, after polarization, the positive is away from the positive plate and negative is of this dielectric after polarization is towards the positive plate. It means if you look at the direction due to field of these charges is opposite, that is from right to left. But in case of the plates, it is left to right. So this is the main difference, because these are also positive charges. These are also positive charges, and they are also producing some field. The direction of that field is from negative plates to the positive. Why? Because from negative side, the portion of the charge or the dielectric charges are plus. So the field produced due to these charges will be in opposite direction. So here it is. The molecules in the dielectric materials have their positive and negative charges separated separately, slightly, causing the molecules to be orient slightly in the induced field. And this is orientation. Positive charges are one side, negative are other. So the electric field due to the induced charges is opposite to the external field, which I have already discussed why they are opposite. So that it reduces the intensity of the external field due to oppositely charged plates, and hence we have the net intensity is equal to the difference of the intensity of the applied due to the positive negative charges, and this is the induced type of the intensity due to dielectric between the two plates. So it reduces the intensity between the two. So it will be the difference will be less than the net induced field will be electric intensity will be less. So types of dielectric. Before we go up to the types of dielectric, let's understand this process once more. So these are the plates, positive plates, and this is the negative plate. These are the charges inner side of this plate, positive. So here is the charges in the inner side of the negative plate, negative charges. Whenever we place any type of the dielectric, polarization process takes place. Positive charges move to one side, negative charges move towards the other side. For simplicity, this negative charge is attracted by the positive charges and they are aligned in the direction of positive plate. So if you look at if the negative moves towards the positive plate, positive charge will move to the other side. So if you look at this, positive charge will also produce some types of electric intensity, and this is another type of electricity which is intensity produced due to the external, that is these plates. So they are opposite to each other. As a result, the resultant intensity of the whole field inside the plates is reduced. So the electric, this is two types of polarization. Dielectric material. We know that dielectric material are made of two types of the molecule. One is polar, other one is non-polar. So a polar molecule behave like a permanent dipole through the electricity, electrically neutral as well as whole. For example, sodium chloride. The end with the sodium chloride is positive while the other end with the chlorine is negative because its formula is NaCl. So sodium is a metal which carries always positive charge, and chlorine being a gas, it is basically negative charge. So these positive and negative charges, due to these charges, they will be positive and negative, and chlorine is negative even when the external field is zero. So on the other hand, a non-polar molecule like water has no electric dipole moment in the absence of an external field. So the center of positive and negative. So what was the polar molecules? Although you are not applying some types of the full field, the types of the molecules have positive and negative charges. But some cases are like water, they are not having positive and negative charges even though when they are placed inside the field. That type of non-polar molecule. So the negative charges, there it is. Negative charges separated slightly, causing the molecule to be oriented slightly in the electric field of the charge capacitors. An electric field due to the induced charges is opposite to the external field we have already discussed. So it reduces the intensity of the external field due to opposite charge plates of the capacitors, and hence this is basically electric intensity next that is applied, and this is the induced due to dielectric. So it is the difference of the two. So here we have discussed about the possible magnitude or the possible quantity of the electric strength of the electric field. It will be less than the strength of the actual field produced by the two positive and oppositely charged plates because the induced electric intensity due to induced charges due to the electric field of the external charges or due to the polarization reduces. So here it is. Sam, we have discussed what happens. This is the polar and this is the non-polar which we have discussed. What's the contribution of the polar and non-polar? We have discussed about the water and the molecules of the water when they are placed inside any type of field. If you look at these are the induced charges. These negative and positive charges are basically induced charges, and due to these charges, the electric field due to induced charges is opposite to the external field. So charges coincide in the absence of an external field, electric field when non-polar dielectric material is placed inside external field, it gets polarized. That is, opposite and negative charges are displayed slightly and their centers do not coincide. Thus, they form an electric dipole. Di means two, poles mean two places where the charges will be. One side it will be plus, other side it will be minus. When it happens when we place it inside an external field. So then what is dipole moment? The product of magnitude of the charge q present in the dipole times the distance r between the charges is called dipole. Here it is. If it is written with p, then it is equal to q, the charge which is placed at a distance q, directed from negative to positive. Overall, the effect of electric polarization on dielectric is between the charge plates of the capacitor is that they, there appears a negative charge on one face of the dielectric towards the positive plate, charge plate, and the positive charge appears on the face of towards the negative plate, charge plate. So these charges on the plate on the faces of dielectric is called induced charges. These induced charges appears an electric field which is opposite to the external field. The external field due to the charge plates. An electric field due to these two charges when they become charged, when they are placed inside the charge plates. The electric field between the charge plates of the capacitor. This causes, this is the effect. This causes the decrease in the electric field between the charge plates of the capacitor. But when the electric field between the charge plate decreases, it increases the potential difference between the plates of the constant charge or constant charge on the plates of the capacitor. When the potential difference decreases, the capacitance of the capacitor increases, and hence the presence of dielectric, the capacitance of the capacitor increases. So this is the main concept. This is the main steps which can be used, which is used to. So from this point, if you look at, this is cause of decreased electric field between the charge plates of the capacitor. But when the electric field between the charge plate decreases, it increases the electric potential between the plates. For constant charge, the plates of the capacitor, when the potential difference decreases, what will be the effect then? The, the capacitance of the capacitor increases. Hence, in the presence of dielectric, the capacitance of capacitor increases. When we place dielectric, the capacitance of the capacitor increases. There is another important question which is asked: what is the effect of dielectric between the charges of the plates? So look, this is basically Q is equal to CV, and capacitance depends on Q divided by potential. If the decrease in potential will increase in the capacitance, and when this potential will decrease with the decrease of the electric field between the charges. So with this, the capacitance of the charges will increase. Some of the questions, so many times these questions are asked, explain what happens when a dielectric is placed between the two charge plates. Or another question which is asked, that is, why the capacitance of the capacitor increases when the dielectric is placed between the two charge plates. So this is the reason. What happens when dielectrics are placed between the two charge plates? It decreases the electric field between the charge plates capacitors. But when the electric field between the charge plate decreases, it increases the potential difference between the plates. And for constant charge on the plates of the capacitor, when the potential difference decreases, the capacitance of the capacitor increases. And hence the presence of dielectric in between the capacitance of the capacitor increases. So with this, I thank you very much for your attention. I hope you people have understood the process of polarization and dielectric placed between the two plates. Thank you very much for your question.